Always true. Always true. True. Always true.
Alright, well that wasn't intended for me to wait that long, but oh, how are we doing today? Jesus. I'm trying to get myself all set up, sorry. Oh. I need to get a different outfit or something. Just always being this way. I don't know, maybe I need to get like a hoodie or some shit for myself. Get my shit all squared away and ready to go. Oh, alright, so apologies. So, we're going to be continuing with our C++ journey. What the fuck we did yesterday. was some very basic. The last thing that we did was some very basic, fucking, like addition and multiplication, using C++. What we ultimately did was we created a few statements and a function that would add numbers. We created two functions. The first one was add numbers, and then the second one was multiply numbers. The way, gosh, I'm like, I don't know why I'm so frazzled. I'm like all fucked up for some reason. You using programming socks? I am not. You know what? I did actually think about making that like a thing. Like, I don't know, maybe not I don't want to own programming socks in real life, but maybe like, I don't know, getting a skeb or some shit of just my character in programming socks. I think that would be kind of funny if I do that at the end of the course. I don't think I don't think I don't know how realistic that is. Because I don't know exactly what I'd be paying for that, but it would be funny as like hey, I completed the course. Here's my complimentary programming socks. uh, anyway, so we're 2.5 hours into this fucking video that is 31 hours long. So who knows? Maybe we can get to there by the end of August. Who knows? Who knows? Who knows? All right, so let me go ahead and open up. I need to open up fucking VS Code. So we're going to File, Close folder, and then Open folder, and we're going to go ahead and open up. I think it's just this one. I think this is the same. Yeah, this is the one that we did last time. Okay. So let's open our shit all proper like. Boom. All right, so we have the video up. We have our code. So what we did, just to go over what I had before. So we had our add numbers. This is with our with the parameters. And then our result is whatever we put into these parameters. We made sure that these parameters are integers, so they can only be whole numbers, or yeah, only whole numbers. Then multiply numbers, we did the same, essentially the exact same thing, but with a different operator. So instead of adding, we're multiplying. So this is our addition stuff, making sure it all works. We actually did this in two separate ways. I totally forgot about this part. But we defined first number as 13 and second number as 7, and then we created different things to add them together. So here we just did we created another value called sum, and then had it print what sum equals, and then we changed the value of sum again by using our adding numbers function from before. So this one was 75. All right. Let's see. Let's run this real quick. So the way that I'm pretty sure this should work, I'll make sure I can remember properly everything that we did. So these don't do anything by themselves. So once we get to the first one, the first number is 13 and the second number is 7. So then the first sum that we have is 20. Then the second one, we created, this is the one that actually prints the line, and it should print to 20. This one is our add numbers, and it's supposed to be this. We've changed what the sum equals, and we made the sum equal whatever the value of this function is. So here it should print the new sum, which should be 75. And then here we did it again, but we put all of that code on one line essentially, where instead of creating a new sum, we just had it print whatever the value of this is. So the value of this should be 127 if my memory is correct. And then we have our multiplication. Int product is first number times the second number, so we have product, and we just had it. This is essentially the same as this sum, but we print a product. So this one should be first number times second number. So this one, it should print 17 times or 7 times 13. So this one should be 9. This line should print 91. This one we created a value called product, where we changed the value of product to whatever the result of this is. So it should be 90. Here it should print 90. And then here we're doing again, we're going to print, it should be 12, 6 times 2. And then here we have we created another line, essentially, kind of in the same vein as these last ones for the things here, where we're adding numbers, but we're using the add numbers function and the multiply numbers function inside of that. So here we're adding up the product of 2 times 5 and the product of 3 times 6. So this should be this add number should print a total of 28. And this product, we're doing a multiply numbers and we're adding numbers together. So this is 2 plus 7 and 4 plus 6, so that's a total of 10, or 9 and 10. And we're multiplying 10 and 9, so that should get us 90. And then here this was another unique thing. This one I think was a total of 200, because I think this is 97 and this is 103. Oh, look at that. I didn't know I could just mouse over it and do that. That's fucking sick. So let's see. We've run the program. So first one, 20, as expected. Then it's 75, because we have this, as expected. 127, as expected. 91, because it's just taking these two values again, as expected. This one, 90, correct. This is the one where it actually prints that one. Okay, and then this one is 12. This one is our new sum, 28. This is our new product, 90. Or not new product. We're not changing the value of product. This is just what these last three are printing. This is interesting, though. I didn't realize I could mouse over what these characters are and get the value of them. That's pretty interesting. Because these are ASCII values, I believe, is what it was. Yeah, I got sent a whole table of this shit. Okay. So we're a little bit I think we're like 45 seconds behind where we actually are, because we're doing input-output for this next lesson. So I have no idea what that's going to hold.
And
All right,
but
that's so I still understand what the fuck I wrote yesterday, so that's good.
On functions, a function has a return value, it has a name, and you have to give it the parameters, and you put the body of your function within these two curly braces. As an exercise, I would challenge you to do a function that multiplies two numbers and call it in the main function here to see the result. If you have any problem, please do ask me. I am going to do
we're square on that. We did our homework.
This covers all we
when you make a variable, it's called initializing.
And I hope you found it interesting.
Interesting.
We're going to stop here in this lecture. In the next one, we're going to see how we can input and output things from our C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about how we can get things in
so we're not going to put anything
and get things out of our.
So a little bit of a mistake we made last time is we got ahead of ourselves and started putting code in here that was just part of the lecture portion of this. I figure we'll wait until the until the next time, until he actually opens VS Code before we actually do anything. Like unless he completely skips over doing that for some reason, which I don't think will happen.
Program, and that's basically input and output to and from our program. We have actually been doing this all along. We have been printing things from our program to the console. And with this technique, you can really think of stdc out as a highway that goes from your program to the terminal. You can basically think of it like this. Data is going from your program to stdc out, and it's going from here to the terminal. And from this, you might get an idea why these less than signs kind of point to the left. Because data is going from your program to stdc out, and these two symbols point to the left. They point to stdc out to signal to the fact that data is going from here to here. I really hope this makes sense, because sometimes these things can confuse people. This is the reason why it's going from your data to stdc out. Data is basically going from your program into stdc out. And stdc out is one way we have to get data from our program to the console. There are many others. We have stdcerr or stdcir. This is what I like to call it.
So C out prints data to the console. C in, reading data from the terminal. Interesting. What does... I mean, I'm sure it'll get explained. So printing errors to the console, printing log messages to the console, and data to the terminal. All right, reading data. So 3 of these are printing, and 1 of them is reading.
And what it does, it prints errors to the console. We have stdc
not
log,
what the
which is
terminal
going
is
to
for?
print log messages. Why do we have these different things? Different programs might decide to format these messages differently because they are different messages. One is a simple message from the program, another is an error. You might want to turn this red to really bring the attention to this message because the user has to solve that problem. Another might be a log message that you want to store in some file or some database. Uses for these things differ, and C++ makes sure to give you different ways to state your intent through the tools that you use. Okay. We have looked at stdc out, stdcr, and stdc log. What does stdcin do? It does the reverse. It's going to take data out of the program and bring that into the program. So let's look at a few examples using these. Here we have an example of printing data from the program to the terminal through cout, cr, and clog. Here we have a hello world message going to cout. Here we have a number going to cout. This is what we've been doing all along. Right. We can also do a variable storing the age, for example. It's a whole number, it's an integer. So we print this out, and the message is going to go from the program to cout. So you can think that things are going from the program before, right? To stdc out. I really want this to make sense.
A variable.
Okay, if we go down, we're going to see that we can use cr to print errors to the terminal. And we might say something went wrong or something along these lines to bring the attention to the problem. And we can use clog to print log messages, and they work the same way. They all use the stream output operator, and it is going to take data from the program to the output stream, really. This is what we mean here. Here is an example of how you might read data and bring that into the program. Here we have 2 variables. One is the age. It's a whole number or an integer in C++, and the other is a string. This is a type that allows you to store strings in C++. We're going to learn a little more about this later, but here I want to use it to really make it clear that you can get things from the outside and bring that data in your program. So we're going to let the user type in the last name, and this statement here with cin is getting data from the stream or from the highway through which data comes into our program and bringing that in our program. And here it should be clear that the flow of data is in this direction. Data is going from cin, and we're storing that in a variable that we have in our program that is called name. We do the same thing and ask the user to print the age, and they are going to print that, and the data is going to come from cin, and we're going to store that in our age variable here.
So if we do CIN, is that just prompting like a typing prompt essentially? I prefer the C way of doing IO more than C++ way, but that's just nostalgia. It's usually worse. How is it much different? Because I'm kind of not confused. It seems like with CIN, the way that the way it's been explained, it seems like the like as soon as you get a CIN or a CIN, I suppose, it's like it'll prompt you like, hey, type something, and like with the line, I suppose this is the command that you have to do, or this is what you have to ask for them to print.
After we collect the data from the user, we're going to print
Yes.
that, and we're going to say hello. We're going to print the name, and we're going to say they are whatever years old. This is what this program does, and I really hope it makes it clear how data input works through streams in C++. Another thing we can do with stdcin is chaining input. And we can use this technique to grab data in one statement. Look at the program down here to really understand this. We have the same variables, age and name. We let the user type in the last name and age separated by spaces. And we grab the data like this. We first grab the name, after that we grab the age, and we're going to print the same things. And we can chain input stream operators like this to grab the data in one go. And this may come in handy sometimes. Before we try these things in
CIN pauses your program and you need to input the thing it asks for. So I assume that the reason that we do int and string is because int, it needs to be an integer, it needs to be a whole number, and then string, I think, is only text, right? Or rather only alphabetical text. Is my understanding, or does string accept numbers as well? Can I make my name like 3204? In C, instead of C out, you used printf hello world \n. String is all text, so it's any numbers or anything that I can put on the keyboard, basically.
In Visual Studio Code, I want to bring your attention to a problem that you are likely to come in contact with, and that is reading data with spaces. What if the user types the name with spaces? For example, you ask me to type my name. I'm not going to type Daniel. I'm going to type Daniel Gakwaya, and your program is going to run into problems. C++ allows to solve this problem using std_get_line, and you use it using this syntax. You're going to pass in the stream where the data is going to go, and you're going to pass in the variable that is going to read the data, and you're going to have this information stored correctly in your program. This might be not making sense yet to you. We're going to go to Visual Studio Code and play with us, and I am sure it is going to make sense. Okay, here we are in Visual Studio Code, and we have our project where we're going to store our files, data input and output. We're going to copy code from our template project, and we're going to put the data in, and I am going to open this folder in.
Actually, you know what, that might be a good idea. That way I don't get rid of all of this math shit that I did. Let me close folder. Let me copy my shit to a new one real quick. I don't want to completely lose all of the work I've done on the other thing. I think that this is I think it's good shit. So let me just copy this over real quick. There. Alright, so this is just it's gonna be a brand new one, but it should still be it should still work fine. Open folder. Project. Yeah, so this is a brand new one. We still have the other one, don't worry. It exists. Instead of CIN, it was scanf %d and variable, I think. I forgot. No one ever uses cn or scanf because it fucking pauses your program. Yeah, that sounds like it would be less than ideal in a lot of situations. Pausing your whole program just to wait for an input. I feel like that's the kind of thing that would exist in maybe like old games like Zork or something. Like old, like, I want to say they were called MUDs. I'm not 100% on that one. But like there's shit where it's like, hey, we're waiting for the user to do something for the game. But like, I can't think of other situations where you kind of want to pause your program off the top of my head, but I mean, I'm sure they exist.
Visual Studio Code. So let's close whatever we have now, and I am going to open my folder. Let's browse there. I am on this folder, data input and output. I am going to select that, and the project is going to open up in Visual Studio Code. I am going to jump to my main function. I am going to take out things we don't need. And the first thing we're going to do is printing data. We have already done this, so we're going to practice this a little bit.
All right, so printing data, blah, blah, blah. Let's get this. Turn 0. Okay.
We can say stdc out, and we can say hello C++20. Why not? And we're going to put an std endl at the end, and remember our semicolon. And here I want you to really put in your head that data is going from our program here to stdc out, and stdc out is going to dump that on the terminal. That's how this works. You can also do a variable. Let's say int age, for example. Let's say 21, and end this with a semicolon. And we can also print the age. We can say stdc out, and we can say age. This is going to be sent to the output stream. And we're going to do std to add a new line character at the end. And we can try and build this before the program gets more complicated. Let's go to terminal. We're going to run the task to build with GCC. And if we hit enter on the terminal here, the terminal is going to go away.
Oh, that was
We're going
blank.
to create a new one. No big deal.
I don't know if it really matters.
And if we do dir, we're going to find our rooster program. If we run it, it's going to say hello C++20, and the age is going to be 21. We are successfully taking data from our program and printing that to the terminal. This is pretty cool. And you can think of stdc out as a highway that is really going to take your data from your program and bring that to stdc out.
Okay,
Like
so this is all stuff that we know.
We're also going to take the age. It's
So
going to
far.
go through stdc out, and it's going to show up here. You can think of this like this. Okay, now that we have used stdc out, we can use stdc and stdc log in the same way. So we're going to say stdc and we're going to say error message, and the message is going to be something is wrong. You may do whatever you want in here. And we have to remember to put a new line character, otherwise data is going to be cramped on one line. We can also use stdc log. It really works the same way, c log, and we can say log message, and we're going to say something happened. And we remember to put std endl and our semicolon. If we build this program, you might guess what it's going to do. It's going to print these things on the terminal, but this might be useful to terminal programs that support features to format different messages directly. The program is going to know that one message is a simple message, the other is an error, the other is a log message. Let's run our program. But before we do that, let's clear so that we don't have noise here. We're going to run the program, and it's going to say the error message and the log message here. Okay, now what we're going to look at is how we can get data into our program. And data is going to be going in a different direction. It's going to be coming from the terminal and flowing into our program. What we're going to do, we're going to do int age1. This is a new variable, so we're going to put in data. And we're going to bring in a string library to allow our program to store strings. The way we're going to do that, we're going to include string. This is how you do it in C++. We haven't really learned about this type. It's a powerful type in C++, but we will get there when we have more powerful tools to really understand it. We are just getting started here.
If you say so, Mr.
We're
Acquire.
going to say std string, and we're going to say name, and we're going to ask the user to print their name and age. You already know how to do that, so we're going to say please type your name and age, and we're going to do std and dl on this. And how we're going to get data in the program, we're going to use stdcin, and we're going to do stdcin, and data is going to be going from the stream to the program. So the stream input operator here points to the right, and the data is going to be going in the name variable because that's what they're going to be typing in first, because that's what we told them to do. So we're going to store the name, and we're going to say stdcin. Data is going to be flowing from stdcin into our age1 variable. Okay, now that the user has given us their information, we can greet them with a personalized message. We're going to say stdcout hello, and we're going to put out their name, and we're going to tell them you are, and we're going to put the age 1 because that's what they're going to give us here, and we're going to say years, and we're going to put an stdendl here. I'm going to grab this and pull this to the left so that we can see our entire program here. That's helpful. So what we are doing here, we are getting data from the user, and we are storing that in our variables, and we are printing the message so that the user can see it. I don't want the first things we did here to disturb us when we build and try this out. So I am going to comment this out and comment the first block of code out using block comments. I think this is the first time we use this, and this is going to be ignored by the compiler now, and it is only going to consider this. And this is...
Wait, why are we doing that? Because, welcome Tara, how are you doing? Wait, so hold on. I think I was busy trying to write this whole thing. Which part of this
going to be,
are we
it's going to be
commenting out?
ignored by...
Error message, stdcout. All the way down to age 1. I wonder why I mean, I'm not against doing this. I just don't understand why. I think the other one was... Oh, I'm an idiot. Oh, like that.
The compiler now, and it is only going to consider this. And this is going to be pretty cool. Let's go down a little bit here and try to build the program. We're going to run the task that builds with GCC, and looks like the build is good. We're going to hit enter, and we're going to clear so that we are not disturbed by this. We're going to run the program. Let's say rooster.exe. It's going to ask...
Oh, I think he has it above this one as well. It's like this. Hold on. I'm gonna go back a little bit.
Me to type. Let's go down a little, and it is... I think this is the first, and comment the first block of code out using block comments. I think this is the first time.
I'm curious why we bothered writing all of that then. If we're just gonna comment it out for this. I mean, all this stuff. I don't even. It seemed like we wrote it for no reason, but whatever. Okay, so int age 1 string name.
And we use this, and
then so we should be able to just run this, but I want to make
this
sure.
Is going to be ignored by the compiler now, and it is only going to consider this. And this is going to be pretty cool. Let's go down a little bit here and try to build the program. We're going to...
Alright, let's terminal run task G++. Build successful. That's good. Let's clear this. Please type your name and age. Rag 300. Hello, Rag. You are 300 years old. Oh, I see where I've messed up a little bit. He has a space in his thing. Oh God, is he discussing indents and their plague on compilers? You sound sleepy. I was a little bit out of sorts. I wasn't sure what the issue was. I was tired after when I woke up. He hasn't been discussing indents, but he has been. There we go. So we do this. So this should give me the spaces that I don't have. So let's clear this. And let's build it again. And we'll do Rag 300. Hello, Rag. You are 300 years old. What if I do like this? Because I think that would be more grammatically correct. It's because you spent 3 hours playing RoboChef? Dude, I know. C++ compiler doesn't care about indents. That's a Python feature. Oh boy, oh boy. Alright. Let's clear this again. Run. No, terminal. Run task. Correct, which is why I asked. Look, man, I don't know. I don't have my chat on the fucking on the on the stream. So, Rooster Rag 300. Hello, Rag. You are 300 years old. Look at that. We did it. Woohoo! Blah, blah, blah. Oh, God, Tara, stop it, please. Stop it, stop it, stop it. I spent 3 hours playing that fucking minigame. We're never playing a speed minigame again. We might not play any minigames ever again for Tron Bon. Okay, so we got this thing, and it looks like it worked properly. I almost wonder if, So, this doesn't work if I decide to give them my full name. Right? Like, if I run this again, if I say Rag Narok 300, it doesn't work. It says I'm 0 years old. It'll catch the first name because that makes sense. Ragnarok 3-1 the first. Look, man. I'm not gonna throw my real name on there, man. This is not gonna happen. Okay? But the point is that it doesn't work if I use a last name. And then if I have my age, that also doesn't work. I almost wonder if so he mentioned that this doesn't like I think he mentioned that this stuff doesn't like spaces, and that we'll have to cover how to deal with that later. Or later, like this lesson, hopefully, maybe.
Run the task that built with GCC, and looks like the build is good. We're going to hit enter, and we're going to clear so that we are not disturbed by this. We're going to run the program. Let's say rooster.exe. It's going to ask me to type my name and age. My name is Daniel. I'm going to type that, hit enter. It's going to want me to type my age. So I am going to say 33, for example.
That's interesting because I've been doing just a space. So if I say Rag 300, okay, so that works the way that it seems like it's intended to. Because I wonder if is that a skill issue, or is that just not intuitive, or not as intuitive as I would have
And
hoped?
it's going to tell me, hello Daniel, you are 33 years old. I put a slash here. We can try and run it again so that I don't have to make that mistake again. So Daniel, that's my name. I hit enter, I say 33, and if I run, it's going to say, hello Daniel, you are 33 years old. I really hope this brings the point home that stdcin is a highway that takes data from the terminal into your program. So this is really what is happening here. When I type Daniel, it's going to flow from the terminal and it's going to go into my variable, which is name here.
I mean,
And
that
when
makes
I type
perfect
the
sense.
age, it's going to
Putting
go in my
putting numbers
age variable
in,
here.
or values
And all
in, I should
these
say.
happening through stdcin here. Okay,
It
one
seems-
other thing we can do is...
It seems weird to me that I can just do a space or enter, and it achieves the same output in both of them. Is that not weird to anyone else? Like the fact that this and this output is exactly the same, even though I used a space versus an enter. I don't know. I don't see how it would work any other way, but it doesn't. It seems strange to me.
grab the data and put that in our variables in one go. So what we can do here is comment this out, and we're going to do stdcin, and we're going to put that in name, and we're going to change these two things and put the other piece of data in age 1.
Okay, let's see. Let's unfuck my shit a little bit. std sin name age 1.
If you run the program, it's going to work exactly the same way, but we are grabbing the data in one line. So let's build to see this in action. We're going to run the task that builds with GCC. We're going to click here and we're going to clear. If we run Rooster, it's going to ask for the name and the age. I'm going to put in Daniel, and I'm going to put my age and say 33, for example. And it's going to do exactly the same thing, but we have one compact line. The last thing I want to show you in this lecture is how you can grab data with spaces, because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear, and I'm going to run Rooster again, and I'm going to say Daniel. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad.
Yeah.
So C++ provides a way to solve this using std_getLine. So let's say what we are doing here. And before we play with this, we're going to comment out what we had here so that it doesn't disturb us in what we are about to do. So let's come down here and say that we were doing data input. This is helpful here. And we're going to go.
So basically all of the code that we've done so far is getting commented out.
Other thing we can do two things and put the other piece of data in age 1. If you run the program, it's going to work exactly. See this in here, and we're going to clear. If we run Rooster, it's going to ask for the name and the age. I'm going to put in Daniel, and I'm going to put my age and say 33, for example. Last thing I want to show you in this lecture is how you can grab data with spaces, because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear, and I'm going to run Rooster again, and I'm going to say Daniel.
I think I went too far back before, but so basically all of this. I mean, I don't know. I don't know exactly.
I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So C++ provides a way to solve this using std_getLine. So let's say what we are doing here. And before we...
All right, so this is all on a new line. Data with spaces.
Play with this, we're going to comment out what we had here so that it doesn't disturb us in what we are about to do. So let's come down here and say that we were...
Yeah, so it's basically all of this shit that we done. Fucked up. This whole thing. All of this pointless. Don't use it.
We're doing data input. This is helpful here. And we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I am going to stdc out. So the way I'm going to grab the data, I'm going to do std get line. You see that we have this function here, and it's going to take an input stream. So stdcin is going to work, and the second parameter is going to be the variable where this string data is going to be stored. We're going to pass in our full name, and this is going to work just fine.
Please type in your full name and age. std and l. std get line. std cin full name. Now, he didn't mention what this age 3 thing is. I'm sure that I think I know what it is, but he didn't mention it, at least not yet.
And we're going to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age3 variable. Once we have the data, we can greet our user using the same message we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring.
So we just want this whole thing again. Put that in here.
Bring this to the same location. It's going to be full name here, and it's going to say age 3. And let's try and build. We're going to terminal, run the task to build with GCC, and we have a problem because we forgot our semicolon. See how this.
Hold on. Run task. C++. We forgot a semicolon. I did not. Let's see. Please type your full name and age. Rag. Narok. 300? Oh, 300. Okay, so that's a little bit more sense, I guess. So because I was kind of working on the same assumption as what we had before, I just did 300 on the same line, but that did not actually work. So it asked me for my age second, essentially. Okay.
Problems might come to you. So we're going to put in our semicolon, and another thing I really want you to see is that you can bring these things to the next line if they turn out too long, like we see here. So I can, for example, put this to the next line, and it is going to work just fine. So.
Oh, wait, that's helpful. What the fuck? That can help compress my shit so that I can show it on, so that I don't have to zoom out. Wow, look at that. I had a dream about going to an isolated city caught in a time loop and freeing the prince so he could go to Antarctica to save the world. Did you just have a dream about Hyperborea? What the fuck?
So what I am going to do, I'm going to try and build again, run task to build with GCC. You see that the build is good. I'm going to bring in our terminal. I'm going to clear so that we don't have noise here, and we're going to run our program. It's going to ask me to put in my full name. I'm going to say Daniel Gakwaya, and it's going to want the age. I'm going to say 33, and it's going to greet me. Hello, Daniel Gakwaya, you are 33 years old. We are able to bring data with spaces into our program. And this concludes what we had to say in this lecture. I hope it made it very clear what these stdin and stdcout things are. They are basically highways that take data out of your program or bring data into your program, and the way you use them is what we've done here in this course. I would encourage you to play with this a couple of times if this is the first time you're doing this. We are going to stop here in this lecture. In the next one, we're going to try and recap on the C++ development workflow. Go ahead and finish up here and meet me there.
Okay, so that is the input-output lesson. I wonder, let's see, Apollo wasn't in it and the city was like Victorian, I think. Oh gosh. Okay, so let's see if we can do something a little bit more interesting than just all this stuff. So this we didn't really do a whole lot with the error and the log. I don't know if there's much to be done with them. I don't know how necessary it is to fuck with the error and the log, like, unless you have something specific. I'm just gonna go ahead and get rid of this because none of this really seems that necessary. It didn't seem that relevant to the overall lesson. I had to feed a whale chicken so it would give me a ride across the ocean. Are you a fucking Legend of Zelda character? What the hell? Alright, so then we can take this and let's uncomment this whole thing. And we'll just call this data without spaces. So, I woke up very confused. I would be confused too. I'm trying to think of something interesting to do with this that kind of combines with like the math and stuff that we'd had before. Okay, so what I'm gonna do, I have to I think I have to do it above the main, if I'm not mistaken. So let's do int. We'll do add numbers again. We'll make this kind of simple. First param, second param. I want to say that's how it was done. Was it param? No, hold on. Let me open what the last one was. First project. Let's open that one real quick. Let's take a look. It's integer first param. Integer first param. Int first param. Int second param. There we go. And then it was, if I'm not mistaken, it was first. I think we called it sum. No, not sum. Int result. Int result. Okay. Int result equals first param plus second param. I want to say that's how it was. Yeah. And then this should, and then I also have to return. Return, is it just return result? Yeah, return result. So we've created our add numbers function. So what I kind of want to try is I want to use this in this input thing that we just did. Birds? Wait, hold on. There were also birds that were radioactive that shat radioactive gems, but we won't go there. Why can't I just dream about veggie? How you doing, Redbird? All right. So, I think we want so this is the data with spaces or without spaces. So we don't really want that. What are some fucking numbers that I should add together or something, dude, that would require me to input them? Because what I want to try and do is I want to create something just really simple for myself. Oh, whoops, no, let's undo that. I want to make a thing that asks me for two numbers, and then I can do my add numbers function with those two things. I don't know. Random.org. I don't want just random numbers. Yeah, I mean, this is about randomness. I want to create something that has some sort of, not necessarily value, but like uses multiple values to add together. Fucking quiero pollo pollo. Alright, here, let's do data with spaces. So std, this is get line. Okay, so do we have age 1 and stuff in here? We do. Let's just get rid of all of this. I don't want to do anything with the data without spaces. I don't think that's very helpful. What's your favorite number? Use anything but that. All right. Actually, we'll just do what we did before. We'll comment out why is all of that there? My favorite number is green. H3. We don't have an H2. Fuck it. Yeah, and then this was full name. And we can do like this. And this one should still be fine. We'll do and Alright, so that's all of that. We're gonna go ahead and create new stuff. So we'll do green is garbage and here's why. 3-hour video. Jesus. I would not be surprised if that exists for some color out there. Alright, we'll get this. So here. We need to create at least 2 inputs. Right? Red is garbage and here's why. 9-hour video about birds. Damn, Redbird, she just fucked you up for no reason. Okay, so let's do std cn we'll call it cat age. I don't know if this even is a thing that this doesn't even work, does it? Because this isn't a thing. Undefined. Oh, where do we have? Oh, yes. Okay, that's right. We need to do int cat age. There we go. Let's do this camel case just so that I can read it better. So I just learned there's a Pokemon hack called Garbage Green, and it's apparently decent to the first search result. Isn't Garbage Green like Pokemon Leaf Green or whatever? Not Leaf Green. Is it Leaf Green? It's like Leaf Green, but you're only able to use the worst Pokemon with like the lowest overall stats and shit like that, like Sunkern. So we need our cat age. What if we do multiply numbers, and then we do this one as, we'll do it as multiply. So we'll take cat age. Yo, do you know any other programming language? No. I am brand new to all of this shit. I have never done anything related to coding before. Well, not never, but like what little I have done has never lasted more than like a week. And except for like high school where I did like some Java, but that was the teacher didn't really understand what was going on, and so neither did any of us. Red wrote another half page of lore, and here's why it's fun. Nice. Pokemon ROM hackers are fucking insane, people. Yes, they are. I'll play a Pokemon hack if Cherubi is all the Pokemon and we can hug her. Aw. So, cat age. So we have to do our C in... So we define that this exists. So we have integers cat age. Oh, what if we do fucking std string cat name? I'll just do a real simple one. Do multiply numbers. I think we do. Nah, man, you know C. What are you talking about? CD's nuts. I'm gonna fucking ban you. Hold the fucking goddamn it. Boom. Timed out for 2 seconds. Fuck you. You dickhead. I'm trying to figure this shit out, man. Leave me alone. So what we need is we also need to print a line. So std was C out. Please tell me your cat's name. We'll do that one first. Std and L. And this one should be std cin. Do I have these reversed? No, I'm good. Cat name. I did this all fucked up like. So cat name. And then we'll do std cin. Wait, no, we already did that. It's this one is std c out. Please tell me your cat's age. And then std and L. And then, so the goal here, warfare in the chats, fucking hell. So the goal here, what I'm trying to do, is I want to create a No, we don't need first param, second param, do we? We do, I think. I think the first param will just be... Okay. Then it's from here we do std c out your cat, and then it's cat name. Is, and then I think from here we need to do our multiply numbers. Multiply numbers. No, why did you do that? Multiply numbers, and then it should be cat age. And then I think we just do 7. I don't know exactly what it is. I think for dog years it's fucking, I think it's like that. In is number years old in human. We'll call it in cat years. 3, please tell me your cat's location. 4, please tell me your daily routine where your cat is unsupervised. We'll see if this works. I need my and then it's std and l. I think this should work. So what I'm expecting, because most of this is all fucked up. So we've created our multiply numbers function. We've defined that the cat's age and the cat's name. What is this? Why is it doing that? Is it not supposed to have a space? See out. Oh, I think I did this the wrong way. I think it needs to be the other way around. I think all of these are backwards. Because the C out, we want to go to the left. I think I had it going the other way. Yeah. So it should be, because we have our CN, cat name, CN, cat age, and we have our your cat name is, however, and then it's cat age times 7. Your name is your credit card number and the funny digits on the back. All right. So this should build. Let's give this a shot. Let's give this a shot. Let's see if this runs the way I intend it to. Run task, G++. Build finished successfully. Let's clear this real quick. Please tell me your cat's name. Nightblade. Please tell me your cat's age. I think he's like 6 now. Your cat, Nightblade, is 42 years old in cat years. Dude, it ran! It did exactly what I wanted it to do! Holy shit! We've combined information from the last lesson and this one? Holy shit! We did it, man! What the fuck? What the hell? Because it took the number that we gave it, and fucking, I think we have an extra space here, but that's a minor typo compared to What the fuck I thought was gonna happen. Oh my gosh. Hell yeah, man. That's fucking sick. Oh my gosh. Yay, dude, for real. I am unbelievably pleased with the results of that. All of this unnecessary, didn't need it. But this, I wonder if I'm sure there's a way to do this cleaner. I figured the reason I did this on 2 lines instead of saying your cat's name and age is because I felt like the I don't know. Maybe there's definitely a way to fix this and make it shorter, right? Because we could just chain the name and age together, I think. Your cat is a middle-aged Japanese salaryman. Yes, he is. He's an adorable middle-aged Japanese salaryman. But fucking... Let me see. If we change this to cat's name and age, see in... I feel like if I did name and age, like I think with this one, it was data with spaces, we have our string full name and our age. When we put in our... So this one is the get line. STD, cin, full name. Now time to code an operating system. Oh god, that is so far beyond my limit right now. Did you see how long it took me to create this? It took me so long. And I'm pretty sure that this is like far from the optimal way to do it. So this was get line. This was in full string std in full name. Temple OS, oh god. Yeah, let me just get right on that. I'm gonna be the next I'll be the next Terry. You just hit him with your car, glow in the dark CIA, fellas. The only glow in the dark computer. So the code on this says you are hello whoever. And this one when it runs, so please type your full name and age, and then it's get line cin full name, and then age. Okay, so all this one did when it ran is it ran it on it did this kind of the same thing, but it didn't have the question between each one, which I think that the question is pertinent to understanding how why I would do this. So maybe the cat's name and age thing wouldn't be that much better, because it would just be creating this whole thing on 2 lines. Code me a program to get all the beef containers to my ship because this little fella I got with me is very stupid, dude. Those puzzles were so hard last night, man. I'm worried what the level 3 puzzles are gonna be like, because if the level 2 ones were that hard, man. At least it wasn't the freaking at least the puzzles weren't the cooking minigame. That shit was ridiculous. Alright, let's clear this and we'll RM register. Alright. Give me a second. I'm gonna go to the bathroom. I'll be right back in however long. Shouldn't be too bad. And then we'll continue this. What I want to try and do, I want to try and finish this chapter, because we just did data input and output, but depending on how long the program execution model and the core language versus standard library, all that stuff, unless these two take like a long time, we should be able to finish this tonight. Or I say tonight, but like today, and then we'll continue with chapter 3 the next probably I don't know about tomorrow, but definitely the day after. All right, give me a sec, guys. I'll be right back. Alright, I'm back. The hell is this? Can't wait for RAG to come back to a fully operational OS called TubOS. Gully sounds like a slur. What are you talking about, man? Fern Gully was like a beloved children's movie. Everyone loves that. Oh, okay. So that was like the end of input output by the looks of it. But the fact that we got this this program to work the way that I wanted to makes me happy.
In this lecture, we're going to explore the C++ execution model and show you a simplified version of the memory model of your C++ program.
That's not a real movie, whatever the fuck you just said. You never heard of Fern Gully? Hold on. You've never heard of Fern Gully? The Last Rainforest, bro? This is a great movie. What are you talking about? How do you not know this? Shaking my head. Shaking my head. Alright, I need to be careful. I don't have safe search on.
Here is how our program looks. It is a simple program. In our main function, it is going to call a simple function that is going to add two numbers. We have seen a program like this before. And when we compile it, it's going to be turned into a binary. This black icon here represents the binary executable, and it is not in the format that you can read with your eyes. If we come back here to what we were doing in the last lecture, we can see our rooster executable binary here. If we try to open it here, you're going to see that Visual Studio Code is going to say the file is not displayed in the editor because it is either binary or uses an unsupported text encoding. So it says, I can't really say this because it's binary. And it says, do you want to open it anyway? If I try to open it, it's going to be just some gibberish. Because this is binary, it is meant to be read by programs. It is not meant to be by IDEs or text editors like Visual Studio Code. So this is the binary file we have here. I tried to put a simplified version of this program to represent binary so that we can follow it up, but it is not in a form that is readable by any human out there, unless you are a machine. So why is it in binary? Because binary format is easily understandable by your CPU. And we're going to see how your program is loaded in memory and executed statement by statement by the CPU so that you can really understand this. So here is a representation of your program. Here we have our hard drive and we have the program sitting somewhere on our hard drive in binary format, and it's waiting to be run by you by double-clicking on it or opening it in the terminal. And on the left here, we see a representation of the memory of our computer. And when I say memory, I mean random access memory. I don't mean memory on your hard drive.
So
this should be
memory, not storage.
This is the random access memory of your computer that is running your programs very fast. So when you double-click on our program, or if we open it in the terminal, the binary file is going to be loaded up in memory. And you see it in red here. This is a representation of that. And it is ready to be run by the CPU. By the time the CPU sees in the memory location, it's going to know I have a program to run. And the CPU is going to start running it statement by statement. It is going to start by the top, so it's going to see that it needs to allocate space to store our integer a. It's going to allocate that somewhere on the memory in yellow here.
Is that why we have to do we have to create our this shit first, the functions? Is that why is that why? Because it has to allocate memory to doing all of that shit? And if we don't, then like if we don't do that beforehand, it doesn't know what to do. I mean, it makes sense that it doesn't do it. I imagine. So, correct me if I'm wrong on this. Any functions that we create like this have to be done before they're called, which, like, that's like that's what makes sense. But we don't actually have to do all of our functions above the main. Like the main block, do we? Like it just has to be, we just have to define a function before it, at some point before it gets called? That's what makes sense to me anyways.
You see A, and it's going to see that it should store in a value of 10. And it's going to do that. You can see that here. It's going to go to the next statement, and the next statement tells it to allocate space for a value B, and it's going to store in a 5. It's going to go to the next statement. It's a variable called C. It's going to allocate space for it, but we didn't specify a value for C. So what it's going to do is store in some junk.
No, you make functions so you don't repeat code. Yes, you have to write the functions before they are called. You can't define a function inside a function in C++, so no add numbers inside main. Okay. So it's like a C++ thing. Like would hypothetically, like Python or something, would you be able to define a function inside of a would you be able to define functions inside of other functions in other programs? Because if we're not, so well, I guess this isn't much of a revelation, but like because this is defining the function of because this defines one function. Hypothetically, if I wanted to do this without a function, I would be typing this over and over again, or not this whole thing, but basically using this code over and over again. Huh, this shit is boring. I'm on DSA using C++. Good for you. You kind of can define functions in other functions, but not like you define them here. Okay. Alright. Well.
Value. The value in there is really unspecified at the moment. It's going to jump to the next statement, and what it's going to do is print some things on the console, and it is going to do that. It's going to jump to the next statement, and it is going to print statement 2, and here it is going to notice that it is going to call a function. I don't know if you have noticed, but the CPU has allocated a special memory location for our function. The function doesn't live with our code here or anywhere near the variables that we have here. There might be a huge chunk of memory between these 2 or 3 things. So the CPU knows that it is going to jump to another location. It's going to ask itself, if I jump to that location to run this function, how am I going to come back? And the CPU is smart enough to store the return address. And that's what it's going to do. It's going to say, if I go to that function, I want to come back to the address 6 and run whatever is after this address. So it's going to store 6 in CPU memory, and it's going to jump to the function. It's going to take the first parameter as A and the second parameter as B. So A is 10. The parameter 1 is going to be 10. It's going to take parameter 2. It's going to be 5 because it is B here, and in B we have a 5. And it is going to jump to the next statement in the function, and it is going to add up parameter 1 and parameter 2. After it adds those things up, it's going to return the result to C. We can see that here. Okay, that's what the CPU is going to do. It's going to put the result in C, and the result is a 15, so we're going to write that in there. And now that the function is really done, it's going to come back to its address, and it is going to jump to the next statement after that. It is going to print 3, statement 3. It is going to jump to the next line and print statement 4. It's going to do that, and by this time, we have reached the end of our program, and it is going to be popped off the memory, and your program is basically going to end. This is how your...
So all he's doing is explaining how we're jumping around, how the program jumps around the memory of this thing. You can define a function inside another function, but you have to make it a friend of other function. You will learn it in OOP. Roger that.
Your program is executed by your CPU. And why am I showing you this? Because it is really good to have an idea of how memory is allocated and used by your program. Another good reason is that some C++ features require you to have an understanding of a memory model like this to understand how they work. For example, you have seen that to call this function, the program had to jump from address 6 to 30. And this is really heavy, especially if you are running a simple function like we are doing here to add two numbers. So the CPU can realize that and optimize this call to the function to an inline function and add these two numbers up right here at address 6 without jumping to this address here. And this may come in handy, and you need an understanding of this memory model to really understand these features. This is just one example I am giving you. You are going to reuse this model a lot in your career as a C++ developer, and I thought it was a really good idea for you to understand it firsthand. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to try and understand the difference between three key components of the C++ program.
Wait a second. Was there no... So this is just explaining how C++ executes programs. You need to define the function before it's used because you get a compiler error if you don't, because the compiler will see you're using a function that doesn't yet exist. I mean that makes sense given that, like, if we try to use this function that we created without it existing, then it doesn't realize that it exists. Because if I put this below this entire thing, it just wouldn't. It would be like, oh, you're trying to call something that doesn't exist. Or even if I do it outside the main, right, and it's below, it just doesn't. This multiply numbers function just doesn't exist yet. So with this whole thing, like, I get that it's like executing stuff by jumping around the memory a bit. And so, like, what is it? Print statement 1. So, like, from here it has to jump to 20 to find A. I don't quite understand what all this video is doing, or why I need to know understand how this whole thing works.
Programming language. Go ahead and finish up here and meet me there. In this lecture, I want to highlight.
And this is core language versus standard library versus STL. So this is the last section. I get the sense this is probably going to be just another lecture and not much on the actual programming side. I don't know, or I guess, I mean, it's all programming, but like not much practical stuff that I will be able to apply and attempt. Let's find
the differences between what we call a C++ core language feature or a standard library feature or an STL feature, because these are terms that come up a lot if you happen to read some documentation about C++. A core feature is really a basic building block that makes up the C++ programming language. You can think of it, for example, how you define variables, the rules that govern how you can define and use a function in C++, the rules that say what you can do and not do with the basic features of C++. That's really what can be qualified as a core feature of the C++ programming language. I don't know if that makes any sense. If we come back in Visual Studio Code, we have a program we have used in the last few lectures. For example,
sometimes it sounds like he's saying Z++ a little bit, yeah. Pointers are variables that contain the first address of another variable. That's why you need to understand each one has an address in memory. So I imagine then that we'll hopefully get to pointers eventually. Integer modifiers, booleans, auto, prefix, precedence associative, if statements, for loop, while loop, introduction to arrays, declaring and using arrays, introduction to pointers. Pointers is chapter 8, guys. We're gonna be at this for a while before we get to fucking pointers. Oh no.
These basic types that you use in C++, the rules that define how you can define a function. For example, if you put an angle bracket here and try to compile this program, it is not going to work because we have violated the rules of the C++ programs. The basic rules that define how the C++ programming language works, the basic types that are defined in the C++ programming language, these little things make up the raw ingredients you use to make up a proper C++ programs. And these little raw components that you use to put together a C++ program are called core features. You can think of them as the foundation on top of which we really build daily use C++ programs. The standard library is a set of ready-to-use, highly specialized components that we can easily use in our C++ programs. And again, coming back to our program in Visual Studio Code, IOStream here is a standard library feature. String here is a standard library thing we have in the C++ programming language. And again, the C++ standard library tries to provide highly specialized components that we can use in regular C++ programs. When you use the C++ programming language, you don't really want to extend the C++ programming language. You want to use it to build something of your own. And the standard library features are things you use to work on your programs very fast. For example, we have used stdc out without really going into the details of how the data is taken from this program to the terminal. That's really advanced and probably complicated, but it is wrapped into this reusable components, and one of them is IOStream, and we can use it relatively easily in our C++ program. Okay, I hope now you have a better idea of what the C++ standard library is. Now, what is the STL? The STL is really part of the C++ standard library, but it is a collection of container types. Think of them as collections of things. And we have a set of types that allow us to store collections. We have algorithms or functions that work on these collections, and we have specialized types that are called iterators that allow us to navigate through these containers, potentially running these algorithms on each element in the collection. This is probably not making sense by now, but you can think of the STL as a highly specialized part of the C++ standard library. And we're going to learn about many features of these things throughout the course, but I want you to have a basic understanding between these three terms. A core feature of the C++ programming language, a standard library feature, and the STL. And I really hope this is clear to you by now. In this chapter, we're going to learn about variable.
Oh, okay. So that was the end of chapter 2. So that was I mean, that certainly interesting stuff. Fucking chapter 1, trying to get my shit set up was probably the hardest part so far. But this was, I mean, just these two programs that we did with all of the, basically doing multiplication and basic addition. It's like I'm back in primary school. Ooh, what the fuck did I just do? There we go. All right. But yeah, so that, I think we're going to call it there for the day. I don't know 100% how long some of these are. I mean, this one, chapter 3 is a little under 2 hours, and that's 2 hours of actual video time, so who knows how long it'll take. But we'll be doing variables, data types, number systems, decimals and integers, integer modifiers, fractional numbers. Ooh, we're going to like 4th grade now, 3rd grade. Booleans. That's like on-off, yes-no type shit, right? Or am I completely misunderstanding? Characters and text. I'm curious what that's going to do. Auto. I wonder what assignments is going to be. Variables and data types memory. All right, well, I think we're going to call it here for the day for C++. This has been an interesting journey to go on for sure. We're only on day 2, so we'll see how much longer it goes. I'll try to get waiting rooms up for other ones. I don't think we're going to be doing any tomorrow. I think tomorrow I'm just going to be doing a bunch of well, maybe 2 streams of Baldur's Gate, but I might end up even only being 1. But yeah, so I hope you guys have a good rest of your days. I hope you enjoyed hanging out with me. I hope it's been interesting to watch what the fuck I'm doing, because this is a little bit. I mean, it just seems it's something that I've always been interested in, but I've never actually done. So we'll do this some more in um maybe not over the weekend, but certainly come Monday. Maybe I'll make this like a 5 days a week type thing, which will be more common than most of my than any one game gets usually. So yeah. With that, I'm gonna go ahead and close this, and we'll go over to here. I hope you guys had a good time hanging out with me. We'll be back with some more C++ stuff over. Oh, well, that was silly of me. We'll be back with more C++ stuff later, and we will. Let me see. Chapter. Oh my God, I can't type. Chapter 3, variables and data types. All right, I have my progress saved. Yeah, we'll see you guys later. Bye.